If we have a question that asks us about a polygon, first of all, we need to have these in our heads. Okay, so first of all is the sum of the interior angles formula. It's always the number of sides that is in the polygon minus 2 and then multiplying it by 180. So if you want each of the interior angle, like I use a small letter I, you basically divide by n. If you have 10 sides, you divide by 10. If you have 20 sides, you divide by 20, so on. And the sum of exterior angle is simpler. It's always just 360. No matter how many sides it has, if you add all the exterior angles together, it's always 360. So each of the exterior angle would be just 360 divided by n. Okay. And the other optional thing you can remember is the number of diagonals. It's always n multiplied by n minus 2 and then dividing the answer by 3. Okay. And the extra one I would like you to remember is each interior angle plus the exterior angle next to it, it's always 180, because this is very easy to understand, because when you extend a line outward, you're making just a straight line. So the orange one is the interior angle and the purple one is the exterior. So it's basically on a straight line. That's why it's 180. Okay. And why I'm asking you to remember it is because then you can convert the interior angle to the exterior angle by just 180 minus the interior, and then use it in this formula rather than using it in this formula here. Okay. And then the last one is the number of reflectional and rotational symmetry axis is always equal to the letter n. If it's 6-sided polygon, so it's a 6 reflectional symmetry and 6 rotational symmetry and so on. Okay. And now let's look at the first question. Now it says, which of the following statement about a regular 18-sided polygon is true? Now, because I have the 18-sided polygon, so n is 18, I can use the sum of interior angles or sum of exterior angle, but the sum of exterior angle formula is much easier to use. So let's find E instead. So we will be doing 360 divided by 18, which is 20. So each exterior angle is 20. So if each exterior angle is 20, so this value is 20. So if you move it over, minus 20, so I is 160. So therefore, I is 160. So this is true. So that's done. And the reflectional symmetry is wrong, because as I said, it's equal to n. Okay, so because of this, that's wrong. And the rotational symmetry is n, and n is 18. The number of folds is 18. So that is correct. And for that reason, the answer is B. Okay, and let's do number 11 as well. Now, they tell us that the interior angle of a regular n-sided polygon is greater than the exterior angle by 120. So the interior angle is bigger than the exterior angle by 120. So actually, if you do the maths on this, or actually we convert it into an equation, it should look like so. Okay, the interior angle minus the exterior angle is 120. All right. So, but you also remember that I plus E is 180, right? So what does that tell us? We have a simultaneous equation. I plus E is 180 and I minus E is 120. And if you do the maths on this using your program number 1 on simultaneous, or you can just add them together. If you add these two together, you will see that the E will disappear. So it's basically 2I equal to 300. So I is basically 150. So interior angle is 150, which means the exterior angle is just 30. And if the exterior angle is 30, again, using the formula that is here, 360 divided by 30, because there's a 30 degree each for the exterior angle. So if you divide by 30, you know it's 12. That's the number of sides we have. That's the value of n. Okay, so if the value is n is 10, no. Each exterior angle is 30, yes. And the number of reflection symmetry is 12, which is n. N is 12, so this is correct. So 2 and 3 is also correct. Okay, so it's basically using a simultaneous equation here rather than going to the complicated sum of interior angle formula. We didn't even touch it. Okay, so we can most of the time escape from this formula, but when we cannot, then we just have to stick with it. So before we look at the 12th question, let's correct the formula for the number of diagonals. Actually, it's n times n minus 3 close bracket divided by 2, not the other way around. Okay, the 3 is on the top, the 2 is on the bottom. And let's look at number 12 now. Let's convert that statement into a equation. So it says that the interior angle is equal to 7 times the exterior angle. So they gave you the relation I is equal to 7e, but we always know the equation, the other equation, that I plus E is always 180. So that's one equation that I have in my hand, and we can convert this equation also into the form of the two unknowns on one side and the number on the other side, so that we can use our program number 1. And once we use our program number 1, so let me just do that. Program number 1, we'll insert 1, 180, and then 1, -7, and 0. You will be able to get 157.5, and E would be 22.5. So we will be using the exterior angle, because again the formula for exterior angle is much easier because it's only 360 divided by n, or 360 divided by E to find the n. So n is actually just 360 divided by the exterior angle, and the exterior angle here is 22.5. So 360 divided by 22.5, it's 16. So you know the value of n is 16. So if the value of n is 16, the number of folds of reflectional symmetry is also 16. But for the diagonals, if most of the time so far in DSE, they always use the n value, which is wrong, because you know there's a formula for it, which we don't normally teach in the class. It's n bracket n minus 3 divided by 2. So if you really want that, the number of diagonals is 16 minus 3 over 2. So it's basically 16 times 13, then divided by 2. So there's 104 diagonals for this case. So number of diagonals. But we don't need to get that. The formula is here. So the number is quite big, to be honest. So normally they only try to test you not to confuse the reflectional and rotational symmetry to be n mixed up with the diagonals. Okay.